All right, so we're going to start 5-2, and we're talking today about transformations of exponential functions. So you just learned in 5-1 about your actual exponential function that we're going to use all the time, which was f of x equals a times b to the x, right? And we had our plus c, our plus c out here. This is our y-intercept for A. B is our constant ratio, that number you're multiplying by, right? And then C is the asymptote. So that's the guy who tells us what our boundary is and where the line has to be when it stops, okay? So if you paid attention a little bit in 5-1, you may have noticed that every time this guy out here was in effect, it made the line go up or down on the axis, right? So when we had functions that were like f of x equals 3 to the x, we know that our y-intercept was going to be 1 and that our asymptote was going to be 0 every single time. But when you have this one out here, like plus 4, then it raised our y-intercept, it raised our asymptote, and all of them went up, right? Whereas if it were a negative, like f of x equals 3 to the x minus 2, everything shifted down. Well, those shifts that we've been talking about, that we haven't really used the word shifts, but we've been seeing the line move, those are called transformations, okay? You may have done something in junior high where you were talking about like slide, flip, and turn and with transformations of shapes. So we're going to use that same type of thing with transformations of our lines, our exponential functions. So these graphs can be shifted across the coordinate plane, up, down, left, or right, depending on what you do to the equation. So the first one we're going to talk about are vertical shifts or vertical translations of graphs. Okay, so that's that k value out here that you have that's been added to the end, or the c, the asymptote, right? It's been added or subtracted. So it says compare the graphs of 2 to the x plus 3 and j of x, which is 2 to the x minus 3. So we're comparing those graphs to the original graph of 2 to the x. So notice how this part's been added on the end, this part's been added on the end compared to the original equation. That's also something you're going to have to know for later on. These are both the new equations, and we're comparing it to the graph of the old one, okay? So if you kind of look, 2 to the x is the one in the black right here, all right? So you can see it has an intercept of 1 right here because this would be our 1 in front like we talked about yesterday. The asymptote comes really close to 0 here, which would be like our plus 0, but it never actually crosses it, right? And then if you have this up here with the plus 3, it shifts everything up 3 units. So your y-intercept was at 1. Now it's gone up 1, 2, 3 spots and become a 4. Your asymptote was at 0, and now it's gone up 1, 2, 3, and it's now at 3, right? That's our asymptote for that one. So it's shifting up if it's a positive k value. And then if you look this direction with the negative 3, it shifts it down 3 units. So again, here was our y-intercept at 1. Now it's gone down 1, 2, 3 to negative 2. Your asymptote was at 0, and now it's down here at negative 3. Okay, so the shifting happens when you have that k, or the asymptote, which we called the other day a c, out on the end. Okay, so if that k is positive, right, every point on the graph on the exponential line or whatever you want to say shifts up that amount. So if it's positive 3, it shifts up 3. If it's positive 8, it shifts up 8. But every single point goes up that amount. So you can see even here, 1, 2, 3, 1, 2, 3, right? They're all going up 3 points. So then in the reverse of that, if k is negative, then every point on the graph shifts down that amount. Okay? So again, this guy, 1, 2, 3. This guy, 1, 2, 3. This guy, 1, 2, 3. Okay? So it's shifting that exact same amount for every single point on the graph. That's that k value, or you could call it the c, the asymptote. Okay? So that's shifting up and down, vertical transformations. The other thing that can happen is your graph could shift left to right or horizontally, right? This is the one that's a little bit more confusing. So if you were to compare the graph of g of x equals 2 to the 8x minus h with the graph of just 2 to the x, when h is greater than 0, okay? Now, what effect does it have on the graph of g? Well, if we let h equal 5, we're doing x minus 5, right? Now, it says minus 5, but you have to keep in mind that it's always going to be minus. Okay, so if I'm plugging in a positive number, I'm actually moving it to the right because positives are on the right. Okay? But even though it says minus 5 in here, so it's kind of tricky looking. It's actually kind of making it look as if we are shifting it to the opposite direction of the graph, okay? So if the number that you plug in for h is a positive, then you're actually going to shift it to the right. Okay? If h is negative, you're going to shift to the left. Now, here's the problem. It's going to look the exact opposite. All right? So, if you have this guy, it says negative 5 here, right? But we plugged in a positive number. So you're going to have to kind of think backwards of what we have. Kind of shows it a little bit when we look at this guy down here. Okay? Shows a little bit more in this one. So if you want to compare this graph that we have, where it says x plus 3 to just the x, to make this become a positive, we had to plug in a negative 3. That negative means we shift it to the left, even though it's a positive when you write it in the equation. So it does become quite tricky, okay? If you're plugging in a positive number, it's going to go to the right, just like the graph. This way is positive. If you're going to go put a negative number in, it's going to shift to the left because these are all negatives on this side. Okay? So same thing happens. Everything is shifted the same amount. The y-intercept, the asymptote will stay the same this time because you're shifting left to right. But every point on the graph all the way across will stay the same. Okay? So it looks the opposite in the actual equation. Be sure to know the value of h. Okay? So as we look down here on the back side and you start to do some comparisons, okay? I want you to kind of think about maybe putting in a little side note here that just kind of sums up what we just talked about, right? So your equation is f of x equals a times b to the x minus h, right, plus k. H values shift left and right. K values shift up and down. Okay? Left are negative, right is positive, up is positive, down is negative. Okay? All right, so let's look at a few of these examples on the back, and then you'll have some homework to try on your own. All right, so it's basically just talking about counting how many places it has shifted from left to right or up or down, okay? The hard part about this that you have to remember is that when they're listing these out to compare them, it's old last. So actually, let's put that differently. Sorry about that. When they're listing them out, they're going to list out the new first, then the old. Okay, so how does the graph of f of x equals 10 to the x plus 9 compare to the original graph 10 to the x plus 3? So this is the new graph. This is the old graph. It's going to be really important for you guys to remember, okay? So my old graph started at 3. And remember, this is my k value, so let's write that again. F of x equals a times b to the x minus h plus k. Right? So this would be our asymptote out here. If it was at 3, if I just draw a little graph here, okay, right? So let's say this is 3, and it's going all the way up here to 9. Well, to get from 3 to 9, it's going to have to go up, and from 3 to 9 would be 6. So it shifted up 6. Okay, hopefully that makes sense because this is our outside here would be up and down, right? This guy here would be left and right. Try to make that tick in there. There you go. Up and down, left and right, okay? All right, let's go to the next one. So how does the graph of a of x equals 5 to the x minus 4, okay, compare to the graph b of x equals 5 to the x plus 6? Now again, this is our new graph, and they're carrying it to the first one, the original, that old one. Okay, so we're talking again about the k value, which means we have to shift up or down. If my original one started at positive 6, so again, let's just make a little graph here. All right, I'm not counting exact, but if that's 6 and it has to go to negative 4, that's down here, right? So to get from 6 down to negative 4, that would be 6 to get to here and 4 more to get to here. So it would actually have to go down 10. So I'm just going to put it shifts down 10. Okay. All right. So same thing. How does the graph of a of x equals 1 to the x plus 10 compare to the graph b of x equals 1 to the x plus 3? So one more time, this is our new graph. This is the old one, right? It's happening up here to the x value. That's the number they're plugging in for h. So it is moving left and right, okay? Well, the old graph, now remember, they plugged in -3 here to make this become a positive, which means they plugged in -10 here to make it become a positive. So negatives go to the left, right? If I'm already out here at -3, right? And I go all the way over here to -10, from 3 to -10 would be 7. So they've moved it left 7 spaces. Okay? So let's go here. Next one. Same thing. This is my new graph. This is my old graph. Okay? Remember, this was a positive 15 when they put it in here, and this was a positive 5 because they're subtracting. So they went to the right because it was positive. So if I have my graph here, right? If I'm at 5 here and I go over here to 15, that means I'm going to the right 10. Okay? All right. So think about it. The hardest part's going to be this shifting left and right. You always have to think about what the number was when you put it in there. It's going to go the opposite direction as what you think it will. Okay? So this bottom section is going to be for you 1 through 6 to try on your own. Okay? Talk about it when you come to class tomorrow, and let me know if you have any questions. Email me anytime you need to.